Welcome back to AI Unraveled, your strategic daily briefing on the business impact of AI on November 27th, 2025. Today, we are setting aside the daily headlines to focus on the single most critical decision in your infrastructure stack, the Silicon Civil War. For 10 years, the answer to how do we train AI was simple. You buy NVIDIA. But that era ended this month, with Gemini 3 taking the top spot on the global leaderboards, trained entirely without a single NVIDIA GPU. The monopoly of the green team has been pierced. We are entering a bifurcated reality. On one side, you have the merchant layer of NVIDIA, offering flexibility and asset value. On the other, the industrial layer of Google's TPUs, offering ruthless efficiency and vertical integration. In this special episode, we are dissecting the specs of the new Ironwood TPU against the Blackwell B200, analyzing the rumors of Meta buying Google chips, and explaining why your CFO cares more about the resale value of an H100 than the flops of a TPU. But before we unravel the silicon, stop marketing to the masses. Start briefing the C-suite. Leverage our zero-noise intelligence to own the conversation in your industry. Secure your strategic podcast consultation now by emailing us at info@jamgatech.com or fill the form in the show notes. Let's unravel the GPU versus TPU ecosystems.
So if you work anywhere near, the intersection of technology and finance, you'll know that for, over a decade now, there's been one king sitting on the mountain of AI acceleration. NVIDIA.
Yeah.
Their GPUs have been the undisputed champion, really driven by this perfect storm, this virtuous cycle of the CUD ecosystem.
And that kind of monolithic dominance, it leads to a dangerous level of complacency.
Mm-hmm.
But then in November of 2025, that landscape saw what our sources are calling an acute structural fracture.
And the shockwave wasn't some new chip from a competitor. It was the performance launch of Google's Gemini 3 model.
Right.
And this wasn't just, a marginal victory. Gemini 3 shot straight to the top of the El Marino leaderboard, hitting an ELO score of 1501.
Which is unprecedented.
For anyone who tracks these things, that's not just winning. That's a statistically significant lead over some serious heavy hitters, like xAI's Grok 4.1 Thinking, which was sitting at 1482.
But here's the real kicker.
This is the part that sent the real shockwave.
It was trained entirely on Google's proprietary tensor processing units, the TPUs, specifically the V5P and the brand new V7, which is codenamed Ironwood.
And just like that, a state-of-the-art stack that completely sidesteps NVIDIA is validated.
Which brings us right to the question you asked. Is this TPU success just a one-off walled garden victory that, only Google can pull off?
Or is this a real viable path for the broader market? Suddenly, the choice isn't just about raw speed, about FLPS. It's this complex, messy calculus of developer friction, ecosystem lock-in, and
most critically, for anyone looking at the balance sheet, asset liquidity and FinOps.
Okay, so let's unpack that proof point first. For years, there was this myth almost, an idea that CUT had some kind of intangible magic you needed to reach the frontier.
Yeah, that you just couldn't do it without them.
That 1501 ELO score just shatters that. It proves, without a doubt, a non-NVIDIA stack can train the most powerful models in the world.
And to really get why the TPU architecture was so perfect for this, you have to look at what Gemini 3 is actually doing under the hood.
Right, this deep think capability.
Exactly, the System 2 thinking mode. Instead of just giving an immediate response, the model performs iterative self-correction. It pauses, it thinks through different paths, and then refines the answer.
That sounds incredibly resource-intensive. You're basically trading compute time for a much higher level of intelligence.
Precisely. The architecture means the model holds these massive context chains and does way more forward passes for a single user query. And the sources show how powerful this is. With that reasoning mode on, Gemini 3 scored 45.1% on the ARC AGI-2 test. Without it,
What was it?
just 31.1%, a huge difference.
So high compute, but the real engineering challenge has to be latency, right? If one query kicks off a dozen internal steps, you need absolute predictability.
You need it, or the whole thing just collapses into unusable jitter. And that's where the TPU shines. Because it uses a functional programming model and static compilation, that's Google's XLA, it provides that predictable latency. The whole program gets compiled before it runs.
Which minimizes the kind of variability you might get with, say, dynamic kernel scheduling on a GPU.
Exactly.
And this is where the scaling question gets really critical. Gemini 3 uses a sparse mixture of experts architecture. and MOE model.
Right, so for you listening, that means a token isn't hitting all 100 billion parameters.
Yeah.
It gets routed to a small fraction of specialized expert layers.
Think of it like a consulting firm. Instead of everyone being in one big room, you have specialized teams spread out everywhere.
Much more efficient, but now coordinated between those teams, that all-to-all communication becomes your biggest bottleneck.
And this is where the hardware philosophies of NVIDIA and Google just completely diverge.
Yeah.
How does NVIDIA handle that?
Well, NVIDIA uses NVLink. It's a fantastic high-speed copper interconnect, and it handles scale-up beautifully. Say up to 72 GPUs in a single Blackwell rack. That's a monster computer.
But the moment you need to talk to the next rack,
You hit a wall, you drop down to standard network protocols like InfiniBand or Ethernet, and that introduces latency penalties. It slows that critical MOE communication down.
but the TPU approach, especially with this new Ironwood chip, seems designed specifically to get around that rack boundary problem.
Its defining feature. The TPU V7 Ironwood uses a proprietary optical circuit switching system, OCS. And this isn't just standard fiber optics. It's an active system that can reconfigure the network topology on the fly,
So it can optimize the data path in real time.
instantly. They can switch from a 3D torus to a twisted torus configuration to perfectly match the all-to-wall demands of the MOE model across a massive scale,
And how many chips are we talking about here?
up to a 9,216 chip pod. The key is that OCS makes that entire pod act like a single synchronous machine. This crushes tail latency, the slowdown from the slowest chip, which is the absolute killer for MOE workloads.
So late 2025, you've got this Cold War. NVIDIA's B200 Blackwell, the general purpose king, versus Google's TPU V7 Ironwood, the domain-specific challenger.
But what's really fascinating, and I think this is key for you to understand, is just the sheer parity in the specs.
They're basically the same on paper.
Almost identical. This idea that one is just fundamentally faster, it's misleading. They both have around 192 gigs of HBM3 memory. On raw FP8 compute, B200 is around 4,500 TFLOPS. Ironwood is 4,614.
Neck and neck. So the victory isn't about the chip itself, it's about the interconnect. It's NVIDIA's copper NVLink versus Google's OCS that lets the system act as one giant brain.
Which brings to the challenge you pointed out, the asset reality. The average listener's thinking, that's great, but you can't buy a TPU.
Exactly. And that gets to the heart of the FinOps problem.
GPUs are a commodity asset. You buy them from Dell, you rent them from hundreds of clouds, and crucially, there's a huge secondary market. They're capital assets.
They're fungible. They're on your balance sheet. You can sell them.
TPUs, on the other hand, have historically been a service. You rent capacity. You don't get a chip to put in your own rack.
But that's starting to change, right?
It is, and this is crucial. Google Distributed Cloud, or GDC, lets TPUs physically live in a customer's data center. They're still managed by Google, but they're there. And, of course, there are those persistent rumors of direct sales to hyperscalers. So that can't-buy-it rule is definitely starting to bend.
But even if the hardware access is bending, the real friction for, 99% of the market isn't the silicon, it's the software.
It's the stack.
CUD has been the lingua franca since 2006. Our sources are clear. Switching to Google's JAX is not a weekend project.
Yeah, calling it a migration is, well, it's a massive understatement. It's a whole philosophical shift. Most AI engineers use PyTorch, which is imperative. You run a line, the operation happens, you can set a breakpoint, print a tensor, debug it easily.
Like a chef tasting the soup as they cook?
Perfect analogy. JAX is functional and stateless. It uses JIT compilation, so the entire computation has to be defined perfectly up front. You can't just stop in the middle and poke around.
So it forces a different way of thinking.
It forces you to completely retool your mental model. It's rigid, it's unforgiving, but that rigidity is what buys you that predictable performance at massive scale. It's an assembly line, not a kitchen.
And that rigidity flows right into talent economics. NVIDIA's developer program has over 5 million members. Finding a good CDA specialist is expensive, sure, but they exist.
But finding a senior engineer who can debug a distributed JAX training loop on a massive TPU pod, our sources call that a recruitment challenge of the highest order. The scarcity of that talent adds millions to the total cost of any big TPU project.
I know one of the old criticisms of TPUs was the inability to write custom kernels. If an operation wasn't supported by XLA, you were just stuck. How did Google address that?
They introduced Palace, a custom kernel language inside JAX. So technically that closes the gap. You can write your own high-performance operations.
But the ecosystem is still the issue.
It's decades behind. Think of it this way. The open source library of optimized CUDA kernels is like the world's biggest, best-stocked hardware store. The Palace library, while growing, is microscopic in comparison. It's a custom workshop. You can build anything, but you have to build it yourself.
Which brings us right back to the listener's core interest, FinOps. Let's really hammer this home. CapEx versus OpEx.
This is the strategic pivot for any CFO. NVIDIA GPUs are a capital expenditure. They are assets that appreciate or, at worst, slowly depreciate. You see used H100s selling for $20,000, $30,000. That's real capital.
And that's a huge safety net. I mean, think about it. If your startup pivots, or, frankly, if it fails,
You can sell them.
you can liquidate those assets. You can recover millions in capital. They are fungible.
TPUs are the complete inverse.
Yeah.
Pure operating expense. You are renting time. When you stop paying, you own nothing. The resale value is zero because nothing else can run them. If your startup fails, that money is just gone.
But for the giants, for the hyperscalers, the total cost of ownership, the TCO equation just flips completely.
Absolutely. For these massive sustained training runs, TPUs often win on TCO. Google controls the whole stack so they can be aggressive on pricing, and the Ironwood architecture is incredibly power efficient.
Better performance per watt.
A lot better. If you're spending $100 million on a compute run, a 20% efficiency gain is a $20 million saving. That easily pays for a whole team of elite JX engineers.
And the customer also dodges the depreciation risk. NVIDIA is always pushing out new chips.
H100, B200, whatever's next. If you're renting TPUs, you never have to worry about sitting on a mountain of obsolete silicon. Google eats that depreciation cost. They manage that obsolescence risk for you.
Okay, let's pivot to the moment that walled garden suddenly felt porous. The rumors in late 2025 about Meta.
Oh, this was a genuine market shock. I mean, a huge turning point in the narrative. Reports came out that Meta, the company behind PyTorch, ironically, was in talks for billions of dollars worth of Google TPUs.
And not just for rental.
No. This included potential physical deployment into Meta's own data centers by 2027.
So what does it mean when the creator of PyTorch, the software that basically powers the entire NVIDIA ecosystem, makes a move like that?
It means several things. First, it's just smart risk mitigation. Meta knows how dangerous supplier lock-in is. This is a hedge against NVIDIA's pricing power.
Sure.
Second, it proves that the hardware and TCO benefits of the TPU are so compelling that they outweigh that massive software friction we talked about. If Meta is porting its Llama stack to run on TPUs, that's the ultimate validation of the hardware.
Then the market reaction
Was immediate and punishing for NVIDIA. The stock dipped 2–3% on the rumor alone, which erased about $250 billion in the market cap. It sent a clear signal. A merchant TPU puts a very real ceiling on NVIDIA's pricing power.
So last piece here, the issue of sovereignty. For defense, for finance, you need air-gapped on-premise solutions. You can't just send your data to a public cloud.
And Google has a partial answer. GDC air-gapped. They physically ship racks of TPUs to your secure facility. They are on-premise.
But there's a huge catch, isn't there? A vital difference between that and true ownership.
It's the defining difference. GDC air-gapped is still a managed service. It's like a satellite embassy of Google Cloud living in your bunker. You don't own the stack. You don't have root access.
Whereas if you buy an NVIDIA DGX Super PU,
You own it. You have full root access.
Right.
You can run it completely cut off from the world with zero vendor involvement. For anyone needing true hardware and data sovereignty, the TPU solution still requires a level of vendor trust.
So to bring this all together, the choice between performance and ecosystem really depends entirely on who you are.
That's the decision matrix. For the 99%, the vast majority of the enterprise market, NVIDIA wins. It's the ecosystem play. You need the optionality, the talent pool, the asset liquidity. The friction of moving to JAX is just too costly and too risky.
But for that 1%, the hyperscalers, the foundation model factories like Meta or Anthropic TPUs win the efficiency play. When your compute bill is in the hundreds of millions, that 20% efficiency gain is worth the entire custom software investment.
So what we're really seeing is the market bifurcating, splitting in two.
It's got two lanes.
Exactly. You have the merchant layer, dominated by NVIDIA and AMD, which is all about ease of use and liquidity. And then you have the industrial layer, with custom silicon-like TPUs, which are pure foundation model factories built for ultimate efficiency at scale.
So Gemini 3 proved the TPU is technically superior for that hyperscale, deeply complex training. But the ecosystem around the GPU still makes it the default choice for almost everyone else.
And that's the final thought for you to mull over. The GPU is still the industry standard, not necessarily because it's technically faster for every single workload, but because it's freer. Freer in terms of ownership, your development options, and critically, asset liquidity. The ecosystem decides the winner in the broad market. Until you get big enough and strategic enough, the that you can afford to build your own.
And that's our strategic deep dive for November 27th, 2025. The key takeaway from this Silicon Showdown is nuanced. If you are a builder, a hyperscaler, or massive lab like Meta or Anthropic, the TPU route is winning. The energy efficiency and optical networking allow you to train models like Gemini 3 at a cost basis NVIDIA can't match. But for the consumer, the other 99% of the enterprise, NVIDIA remains the king. The ability to hire from a global pool of CUDA developers and the fact that an Hone 100 is a liquid asset you can sell if your startup fails makes the GPU the only rational choice for risk management. The ecosystem decides the winner until you are big enough to build your own ecosystem. This brings us back to our core mission. Stop marketing to the masses. Start briefing the C-suite. If you need to position your brand as the authority amidst these shifting market forces, we should talk immediately. Leverage our zero-noise intelligence to own the conversation in your industry. Secure your strategic podcast consultation. Now, the link is in the show notes. Finally, if this briefing helped you unravel any aspect of AI today, please like and subscribe to AI Unraveled on your preferred platform. This podcast is researched, produced, and created by Etienne Newman, senior software engineer and passionate soccer dad from Canada, and we'll be back tomorrow with your next strategic briefing.